So, you know, picking back up on part three here. One of the things that it's kind of wrapping my head around, the segment between switch three and switch four, it's acting a little weirder than I anticipated, right? So if we go to the command line again, the link between switch three and switch four, off of switch four's local interface, it's 0, 3, right? Off of switch three's interface, it's 0, 1 or 1, 0, right? That's connecting to switch four. Now, 1, 0 is in the alternate blocking state. You notice that they both have equal cost to the root. Show span VLAN1. They both have equal cost to the root, which is 156, right? Now, what's a little confusing to me is based off of design, this port technically, this port technically should be in a designated position on 0, 3, because equal cost to the root, 156, 156. Now, the one who would get the designated, in this case, would be switch 3 because of the lowest bridge ID, which should look like this. But it doesn't. For some reason, it looks like this, which isn't wrong because it isn't bad because it's still blocking. But I gotta do some more research to understand why that is the way that is, because based off of design, technically this should be an alternate. One of these should have been a backup port. So gotta do some research. Hopefully somebody, maybe if one of you guys know, drop a comment and give me some insight, because I don't know and trying to figure out why. It's a little weird. Never seen that before. Well, maybe I just never paid attention to it. So switch 5 and switch 4, or let's go ahead and go to switch 5 now and do the same thing. So CDP neighbor. Show CDP neighbor. And that's if I type the command. Show spanning tree v1 and 1. Right. So we got our forwarding ports, which based off of the design, switch 5 should be in all forwarding state, with one blocking port on the port channel, which we see here. Come around. Which we see here, which is that port channel facing switch 2. And the root port is the port going towards switch 1. And if we look at our CDP neighbor, the root port is 0, 0, 0, which is the one going to switch 1. The blocking port is going to be this first port channel, which is the way it should be. Oh, you know what? I realized I did again. I did not pay attention to this config, because switch 3 should not have a port channel built, and it damn sure does. Wow. Okay. Okay. This is what's throwing me off, man. This is why I say configuration makes a big deal, and checking the double check. Like I said, I went into this with a very little preparation, and that was because I wanted to give you guys a real world of how I do my labs and how I go about, configuring my devices. And this is one of those trial by error things, especially when you're practicing for things like the CCIE lab. You got to be able to recognize things on the fly quickly, and to fix it within a decent amount of time without wrapping your head about it and, from here jumping to Google. So in this case, this was a configuration error. I kind of just went too fast, and I meant to keep the two links out of the port channel for switch 3. So we're just gonna unbuild that port channel. Go on to switch 5. Config T interface 0 interface range Ethernet 0, 0 dot through 1 no channel group. So his interface is going to be 0, 3 through 1 on switch 5. 0, 3 through 1. Interface range Ethernet 0, 3. Should unbuild the port channel. So spanning tree VLAN 1. We're going through the whole listening, learning, blocking, forwarding stage and all that crap. Now it should take about 30 seconds. And now the topology should go to where we had it before, where switch 5 should be forwarding on his ports. And then switch 3. So switch 5 should be forwarding, right? Good. Perfect. Okay, now that looks much better. And then we got the two blocking the way it should be in the map. Should have paid a little bit more attention when looking at that. I thought something was weird, but I thought I was just overlooking it. But now we see it. All the ports are forwarding for him, except for the one port channel that's in the blocking state for switch 5. Right? Perfecto. Now, switch 6, same situation. So CDP neighbor. So spanning tree, VLAN 1. Now, perfecto. We see all our ports are forwarding on switch 6, which as it should be. We have no blocking ports, and everything is pretty much following. As you can see, switch 6 is going to be the one that's going to get the biggest hit, because most of the root ports are facing switch 6, so most of the traffic is going to end up going through switch 6 to get to switch 1. So that's going to be our bottleneck right here. I can already recognize that. How do we fix this? Now, what we can do is one or two things. We can go through and start modifying a crap load of we can modify the bridge priority, or we can go and do the commands spanning tree VLAN primary, the VLAN primary to make one of the root bridges primary. And based off of the design, based off of what we want to see switch 6 and switch 5 become the root and the backup root for the STP domain, because essentially the way it's designed, we don't want our access switch to be the root of the network. So go through and we'll start clearing this off. Start clearing this off here. That stays, because now we got an idea of what the topology is doing. We can go through and start it from scratch, and we'll go through the whole election process. Now we're gonna have a different root bridge, right? And a whole different root bridge selection, root port designated port selection. So switch 1 is no longer the root, and in this case we're gonna make switch 6 the root. Perfecto. So we'll go through and black out all these lines again. Everything's forwarding. We got a nice lasty routing loop, switching loop going on here. The spanning tree has just been disabled. Never do this in a production network. Just an FYI. With the amount of TCNs going in, depending on what your current STP topology is, you can cause some network disruption. And if you don't have things like port fast or anything like that enabled, anytime that TCN is received, the spanning tree ports go through that they start going through the whole election process. And like I said, it could potentially cause disruption if the link was directly connected, directly affecting your path to get to the root bridge. So something to keep in mind when modifying this stuff. So one of the things we're going to do is we're going to configure this guy to be the root, and they make you do it, I think, in multiples of 4096. I can't remember, but essentially, usually whenever you do this priority, it's usually 4096 when you do this switch port primary, and that sets up that to be the primary root, right? All right, good. So what we're going to do now is go through the whole process of electing the ports as we did before. Perfect. So we got our designated port here. We have a designated port here. We have a designated port here. And we have 2 DPs here. Right? So our switch port, our root is forwarding all its interfaces as it should. Perfecto. Did I add an interconnect between those two? I didn't. Don't need to. That's cool. Honestly, I should, but for this example, we're not. So, and when I say interconnect between switch 5 and switch 6, and that's because it would affect switch 5 to not have to go through any of the access switches to get to switch 6. Let's go ahead and do that. We can configure that, because based off of good design, we want to make sure that our distribution never actually touches our access layer. Based off of good popular design. And then we got another here. And since it's going to be another 10 meg link, we're going to add we're going to make that 100. So let's go ahead and get those interfaces configured before we can continue. That's going to have a hindrance on our network. So on both sides, Ethernet 1, 2. So 5 and 6. So we'll go here, config T, interface, Ethernet 1/2, switch port mode, shrunk, switch port encapsulation, switch port trunk, encapsulation .1Q, switch port mode, trunk, and no shut. Okay, so switch 5. Config T, interface Ethernet 1/2, switch port trunk encapsulation .1Q, switch port mode trunk, no shut. Show CP. I may not immediately find him, but it should. Not immediately, but it should start to see him within a minute. 60-second interval. But I digress. So let's go back to the diagram and figuring out our root ports, right? Wait, delete that. Good. So let's go. We got all our designated ports on our root bridge. Let's now do our root ports for our non-designated switches. So same thing here, switch 1. Let's start calculating it. We already see, based off of already here, 56 is our cost of the root. That's our root port. Switch 2. Same thing. We got 100 here, and then we got 56, 100 there. That's going to be our root port. Perfecto. Switch 3. Same thing. We see here, we got 100 here, we got 100, 200, 100, 200. Our root port is definitely going to be here. Perfecto. Switch 4. Same thing. We're going to go here. Now, switch 4, same thing. Remember how we had the interfaces with a matching root bridge in the MAC IDs, and it went to the port ID. Now, we're going to have the same scenario, except instead of doing the alternate port, we're going to have the backup port. And, you know, based off of the last scenario, we remember that Ethernet 0 facing switch 6 was the root port because of the advertised port ID coming from switch 6. So, same case here, that's going to be the root port, Ethernet 0, right? And then also switch 5, which is here. That's going to be his root port because he has his cost of 100. So now we got that network figured out. And we're going to do another part of the video. It's coming a lot longer than I anticipated, but it's all going to be well worth it because to me, this going through spanning tree this way, it just gives you a really good foundation. So we're going to start with the next video here shortly on the designated ports for the non-root bridge selection.